the joints. Give me 2 seconds.
SDN's been in play with the top 7 Titan data centers for about 5 years now. Like, to make their data centers look singular. The ability to do tray-based innovation for accelerators, both security and media accelerators. You may need a tray in the rack that accelerates more things than just a basic cloud company accelerates. Work within your 5 or 10% with that type of acceleration. And then network performance. Nobody will be better than you on network performance. Wireless or wireline. You get a premium for that. You can make business happen with that. Last is, you want developers on that platform? And this is the key thing on this. How do you get developers in that platform on your network that continue to create services? Okay. All right, here is the master list of what's currently available in the hyperscale RSA line card. This is not an advertisement, but it's becoming real with what's coming out. 3 routes you can buy off the shelf completely, modified, or do it yourself, do it your own way. And number 3 would be kind of bought with NEBS requirements in the past. Maybe I need to look at that now. I don't know, it's your call. But the fast movers will probably land in this two routes there. So your strategic departments and your procurement departments, I'll look there first. Okay. All right. Some examples of realness. Last week, this was And there is an innovation ecosystem that you have to think about. I'm talking to telcos here specifically. You don't get a developer, even internal developers on that cloud platform, you really have not won the game. Yeah, you can move a bit more efficient, but you aren't making any incremental revenue or profit. So you need to figure out a, call it telco grade platform around this stuff. And platform, I mean a development platform that is profitable for you. Okay.
So Kevin, this is an example on how fast things move for the Open Institute. So the foundation is about 4 years old. The Open Grant on third, then Brian fourth, Catholic second. Those three SD cards or IO size IO cards on the second generation. You could almost argue that third generation was kind of an undocumented version of built in. The boards, the sleds that go into open that are on the third generation. Right? So the pace of innovation is actually faster than less. And new product ideas that the least coming out. Everyone sat back and tried to write standards and that's what it looked for. But again, just reinforcement that really about this community have end users, have suppliers of the same thing. And by talking very consciously about it, but something that is this to want to solicit more interest in aggregate demand and just more support to get more support.
Questions? Curiosities?
So, number two.
Yeah. Yeah.
So, how much of Telco first, some sort of depth.
Mm-hmm.
And the subsequent time, still in the progression of the second environment.
Yeah, that's a good question, and there's a lot of debate about that, but I think it's in that 90% current commercial, 10% DEVs. DEVs has a couple curious natures to it. One, it's generally US-based, but other countries picked it up because, it's the solidified architecture of times past. It's also based on insurance. The telco central office burns down, burns the high rise with it. Well, you put in just anything but NEVs, probably going to have more of an insurance problem. Right? So there's an insurance impact. The question is, well, how much of a risk do you have? And how many times does a data center burn down? Even with current equipment. So that's changed. NEVs was great because it was, the E911 system, the emergency system built around that most of the time. So, a lot of people use their mobile phone to call 911. How reliable is that? So there's a lot of things changing underneath it. There's been a lot of curiosity. As I mentioned in the front, I have a couple dozen hot interests in hyperscale across my domain. I touch anywhere from China to Europe, down to Florida. NEVs is our conversation is what's not to do. What's not to do. What not to do. How do we get around it? What's not to do. There are embedded companies that will pick up the design, you spend a lot of money with them on NRE. It's likely if you can get that small spiral going, a few people will buy that. It's not something Intel's driving. That 1, 2, 3 line chart, we're not doing number 3 actively. We as a company will supply technology equipment into them, but somebody's got to do the frame, the box, the hardening, the testing, and that's not Intel. We took ATCA as a collective ecosystem supplier through NEVs. Painful. Intel's not going to do that. Somebody asks me, are you going to sell any NEVs equipment? I would say, not enough. Somebody else can do that. Good. Other questions?
Thanks,
Okay.
Kevin.
Thank you very much. You can get a copy of this. Thank you very much. Catch me afterwards.
Okay, we're at the top of the hour. Why don't we take a 2-minute break? You guys can stand up, stretch. We have 2 people coming in the room and give Tom a chance to get things set up and ready to go.
All right.
Microphone's open.
Another 10 feet short.
Oh, so it's sending it out to here. It's not going out to
Okay. Okay, yeah. Yeah, yeah, yeah.
Well, last time I was still you know the briefing center, the briefing center. Is that also?
Okay, well, so, also, you look at the building, so we can.
So that's on one screen, but not on the other.
So, eight, I don't know about it. No, no, building, which then you have our managers, service, employees.
Yeah, I've been inside it.
Okay, sure, definitely like transfer that over to that.
Let's just leave on one. That's
So then in the front building, that's how the square, I have the. And so, in that front building, in the lower wing, is 5 U-verse, or, you know, it's like not test lab, it's the duplicate of the actual system.
Remember, hold on.
So, so AT&T decided that they needed to replicate that facility. Instead of replicating, they're like, well,
Are people okay with just one screen? Not with you guys.
they're okay.
They're both.
Oh,
There was-
what?
They work. Yeah, both of them.
Second.
All right, not so fast.
Oh, man. Okay, just wait. Yeah, so. Instead of stopping.
Don't touch any.
Yeah,
That bombshell.
Let's get started. Let's get started. I want to thank Tom Entles for volunteering to come in today as our first meeting. It's actually a great segue to the conversations that we just heard from Kevin, in that I think AT&T is realizing the challenges and the opportunities and is ready to go embrace OCP as a way to work across a much broader, bigger community and establish some partnerships. And so it's very exciting that you guys are here today. I say you guys because this is what we talked about earlier. They've teamed up with one of their key suppliers, PMC Sierra, and going to talk about some NFV stuff that you're doing, and talk about what we can do as an open community. So you got as long as you want. You're the last one on today. So,
Well, I'm between you and drinks. Oh,
Yeah.
no.
you're between them and an opportunity to get in and see some of those other people.
Okay. Well, sounds good. First of all, thanks for having me and for letting us come and talk a little bit today. And it's true, this is like an interesting journey, and I feel like a newbie, not like used to going to standards, frankly. Gone through them for lots of years, and I remember the cycle. So you get an idea, go to some standards committee, and you spend 5 years with another standard, maybe, lucky, great. And then another 2 or 3 years getting products that meet those standards. And by that time, the next thing has come along, and you're going, why didn't we get the whole thing? Right? So what I'm going to do today, though, is going to look at sort of 3 different things. One is a kind of a big picture, how we see things changing in our world, and what it means for us in terms of infrastructure. And then I'm going to look at look at that pattern and talk about how we can apply it to things that aren't typically found in data centers, but are really near the hearts of carriers. And then lastly, and there is sort of the reason I'm standing here, that we realize that ways that we went about creating new value with Telco are just not practicable anymore. And that the way to move forward now is around collaboration, around community, around doing open source when it isn't something that differentiates us as a company. And so that's what we're doing. And up here at the North Pole, collaborating sounds good when you're doing it. So why don't we get started? I don't know that I've introduced myself. I'm Tom Anchos. I'm with AT&T. I've been there at one AT&T or another for a long time. And I'm going to talk a little bit about how OCP can play in and why we thought about it after developing technologies and strategies around SDN. So I mentioned this. I'm going to talk a little bit about what's happening in our ecosystem. We already heard that in the previous talk, but it's worth looking at sort of what does AT&T think is really important for us to do in the next several years. And then you probably already know all about SDN and NFV, but I'm just going to recap some of the highlights there because it's going to be used in the next segment, and that is sort of the meat and potatoes. How do you refactor the kinds of systems and equipment that has been traditionally telco? And then finally, I'm going to practice what I preached. I'm going to show how that refactoring can be applied to GPON. And it even looks like it's still running, right? So we have a demo for that as well. Why don't we start off with AT&T business imperatives? If you've seen our CTO John Donovan talk, you've probably seen this chart before. You know, I lifted it there. You always lift them to your attention. Very valuable. But there are three things across the top that we think are really important. We believe that we need to open our network, that we're not going to be the only innovator in that marketplace or in our geography, and that instead of dealing with over the top as something that bristle against, we become something still keep our business, our model. The way we think we're going to do that is by opening up the APIs for a software free and provided WebRTC. They want to provide an OpenStack interface. You want to run work. We need to simplify and we need to scale. So as we looked at a typical telco network, you'll see the chart in a little while. If you've gone into one of the central offices, you'll see lots and lots of different kinds of equipment. They're just racked and stacked. They're just vertically integrated. There's dozens and dozens of them. And there's very, very little reuse, even though inside you'd be surprised at how much gets done over and over and over again. Basic quality constructs, basic management constructs wind up being redeveloped, reapplied to the same problems or slightly different problems as unique products over and over. And it hasn't been lost on us, DevOps operational model and the sort of agile development models, sort of waterfall kind of thing I mentioned right at the beginning of the talk. And it's sort of the standard telco was, I've got a new idea. Let me start a standards body, right? That doesn't work. So we are looking at these new operational paradigms, figuring out how to try something small and simple. It doesn't have to be worked out 100%. We'll see if it works, and then build upon that. If it doesn't, let it fail. On to the next thing. And we see in our environment some significant stressors in terms of the Internet of Things and video. And so we call the form, the Internet of Things, our 10 billion lives problem. And so, so if I have a wireless service, and I have one, I got one of these, right? And if it's one of these kinds of devices, people are really happy to spend, tens of dollars per month for a relatively high-value device to put up. Do you think the power company's going to spend that kind of money to have the meter read once a month? I don't think so, right? So the 10 billion blinking lights problem is one about a lot less argument for those 10 billion devices. And the only way to do that, if you look at the architectures today, you know, this thing is well specified through GDP. All the carriers in the world do the same thing, right? And I can tell you the economics of that architecture don't scale to 10 billion. They don't. So something needs fixing. We know that. And then last but certainly not least, we want to increase value. We lamented for years, oh, we've been relegated to a price company. We don't like that so much. But so this is a big chance in a lot of ways, right? That what we see is, to see the next charts, the new kind of infrastructure doesn't just allow you to shuffle packets. It allows you to add value. It allows you to host workloads. It allows you to host smaller tables, and then do innovation in terms of application. And so how do we think that we're going to meet this imperative? If we don't do this, we don't have a business, not in the long term, right? So we believe that it works this way, that the kind of infrastructure that we deployed before has got to go away. The whole business of I'm going to buy a box to support a service, that has to go. So I need to have an infrastructure that I use over and over from one service to the next service to the next. And that way, if the service doesn't work out, it's no big deal. That infrastructure didn't have to get written off the books if it failed. And so therefore, the barrier to entry of rolling out a new service isn't, I have to make absolutely sure that I can keep the structure for at least the time it takes to write it off the books for example. So that's pretty big. Okay? And that's how we decouple, that's in it. You decouple hardware from software. You find an infrastructure that can be over and over again for lots of different, what I call telecom workloads. And then separation of control forward. Some things, a lot of things do lend themselves into general compute. Some things don't. And you'd be surprised how many boxes there are with specialized ASICs that shuffle packets really fast, right? Comparative speeds. But it's really running control software that differentiates it from being, or discerns it's going to be an Ethernet switch, or an IP router, or an MPLS router, or a P gateway. You know, the ASICs and the silicon that comprise the box were very similar. Why did they have to be siloed boxes again? SDN offers me a chance to change the control plane, change the behaviors of the hardware from external to internal. Finally, we think these two things, SDN, are even more powerful when they're put together. They're good all by themselves, but when you combine them, they get big. So jumping through those, I probably won't belabor the next couple of basic principles of SDN, and I'm going to follow that up with, and then we're going to talk about refactoring. So SDN, and I borrowed this chart from before, what we had were boxes that had deployed components. And they had at the bottom was hardware. And then from the same vendor that created the hardware, there was an operating system of some type, probably for, iOS or or even other products. And then there were applications, right? The applications might turn that box into a router or a switch or a P gateway or what have you. But the thing is this, if I wanted to be able, or at least in talk to one another, I have to coordinate how those applications work. I have to come up with a distributed system. And then how many thousand RFPs have we got now with the IETF now? I need that many specifications on how we talk to each other so that the distributed systems actually work. In the afterworld of SSN, I will have to totally hardware CPUs. Okay? I want to be able to turn this into a router behavior, and OS behavior. I have a common network operating system. And the apps, because they're expressed over that open interface with the hardware, don't necessarily have to have IETF or work. I can program a brand new behavior, something that's forwarding that isn't IP, that isn't, right? And then I can have that expressed in forward structure. That's powerful. That's all right. So now NFB, you've probably seen these pictures too. The SE folks have published them before. If I look on the left side of the chart, I see the menagerie of devices, all kinds of devices. And what I want to do is not have to have all that different hardware. All that comes with its unique training, its unique sparing, its maintenance programs. It goes, you know how it goes. It goes on and on. It's to the point where, from our IT perspective, we have a new box. It's millions of dollars to operationalize a new box, right? I want what you got. I want a lot of high volume standard infrastructure on which I can have network functional software, right? And that software then can embody all of those telecom workloads that I need to get done for my customer satisfaction. And guess what? We're actually making some progress here. Okay? There's already NFV things out there. There's already high volume processors and storage. But by and large, the problem I'm facing right now is that most of the time, this virtual appliance or this virtual machine is essentially the same software that used to run this. All the I/O grabbed out from the bottom and ported to x86. And so whatever that, so I still have all these different variations of virtual network function. And they're still really complex to write this out. And so what happens when you've got a complex problem for a software architect? Usually you break it up, you modularize it, and you look for reusable components. And that's essentially where I'm going to go. I'm going to start, however, with this for you NFV infrastructure and kind of lead you through a fairly quick path from how you get from a data center mentality or data center architecture to one that serves telecom workloads. So this should look fairly familiar, right? That in a typical data center, you've got servers, you've got storage, you've got this thing called fabric. Of course, you know, all kinds of network. Right, so you've got these switches, spine switches, and then often they go out front through firewalls and routers to connect to favorite carrier. All right, but if I want to use this to actually do carrier work, to do telecom workloads, there's a problem that the part that was connected to the carrier doesn't scale, right? The fabric in data centers scales out east to west. It doesn't scale out north to south. And so this is where I've got all the major bandwidth. It goes back and forth to all of these ports down here, and this winds up being a bottleneck. So what do you do about that? Well, you say, obviously, I'm sorry. What you can do is say, let's think of these things as a new kind of device for the data center, and then let's move them so that they actually become more normalized in that fabric spot, right? So instead of everything having to focus on that, I'm going to use the part that scales out here. And in the telecom, I've got some things that are low speed, and they're fine in this location. But sometimes I want to aggregate things up to very high speeds. Maybe it's 6 there, right? This is actually not all that different from that. But unlike before, this now applies actually a lot of part of your scale out architecture. No longer a sort of unique north-south. You've got your infrastructure. Okay. So there's some really fun things when we start using the fabric. The data center people architecture that I can hash traffic through fabric. I can create single flows that might go through as WDM systems that are comprised of more bandwidth than any individual fabric support. And use destiny control and orchestration already been done. I can actually set these things up so that real simple switching through this infrastructure is not that hard. So here's my trick. This is now we come to the refactoring thing. On the left side, we see one of our favorite boxes from right now. And on the right, we see this new infrastructure. And essentially, all of the different parts that make up that vertically integrated box are mapped over here to the right-hand side. At the top, there's probably a control and management part in this device. That control and management is by SPN control and SPI orchestration. The device had a backplane or fabric part, and I'm going to make use of the same fabric that got used today. Why not? And then I just talked about it, fast I/O, slow I/O, and then on some of the routers, and especially on things like P gateways, broadband network gateways, there are often applications that are embedded to these devices. And I can run that in a server. So good. And then here's the place that this solves, right? Is that I can now do that trick from before. Remember the early picture from the SCNFE group? This is the one infrastructure, which is, a bar vector cell from I can now map all these different kinds of disparate boxes. And okay, some part of them does remain unique and different, but all those parts that aren't, all the backplanes, just the backplane, right? All the I/O, different brands of I/O cards or blades, they didn't happen. And some of the control planes, authentication, 802.1x, we'll talk about in a bit, multicast control, OSPF, and BGP, those things don't have to be individualized and rewritten so they keep up.
What are some examples of fast and slow?
Okay, that's a great question. So in just a few minutes, I'm going to make an example that slow I/O might be GPON, which is a consumer broadband access. And I think that a fast I/O might well be 100 gig, 400 gig lambda. If I want to be really sort of over the top aggressive, I might see a bonder shell. And I use the fabric to focus lots of threads onto the plates of lambdas on metro or long haul now. So kind of funny, right? But this is one of the bits that I mentioned earlier. There's 5 or 10% of telco that doesn't get easily borrowed from what's been going on in data center and OC. And that's where I think a lot of it is. That in telecom, we've got things like GPON, the cell. Lots of PHYs that get used on the outside plant. With the mobile, there's CIFRI, great radio heads, right? There's various types of
So in the case of fast I/O, we go to another location.
Yes. So if it's a fast I/O, it's probably a link that makes up, say, a metro topology. So all of the central offices that make up the metro would consider fast. And low I/O, more likely than not, is sort of likely to be a customer of some kind. Yes. So the fast I/O could be connected from uplink. This telecom networks also have a hierarchy within their institutions, a local or a national network, a metro, national, and international scale. And any other questions? Okay. So it goes back to the beginning. Sum is more than the parts, right? It's like chocolate and peanut butter. So NFV helps with converting the network functions from dedicated hardware to software, right? It's that Mark Andrews comment that software is going to eat up the world. And we think that's going to be with a lot of telecom functions. And then separate SDN, separation control authority for programmable networks allows us to have this complementary um, NFV infrastructure. So this NFV infrastructure allows you to host lots of different telecom workloads, lots of different functions, if you will. It allows you then to tie them together, codes, services, and capabilities out of these small components, and therefore you wind up creating sort of scaffold control, able to be very dynamic. And a lot of this is not so new, right? The SCNFV and OPNFV have started going on this trip. So, I guess I'll take a pause, and then what we'll do is sort of take a sort of down, right? We talked a lot about that. That was a lot of high level, a lot of hand waving, but what does it really mean, right? And that's what the next action will go into. Are there any questions or comments so far? Makes sense.
How happy are you?
The question was, how happy are we with the ecosystem keeping up with the vision? Gosh, it's real hard to get if you think about the things that I mentioned before, there are new technologies, new ecosystems, there are new operational models, right? There's new business models because the customers are really not that happy with all you can eat for a fixed monthly price, or at least let's say that won't continue to work necessarily. You have to be able to do things like advertising, such as so many things change at once. It's like tremendous. It's like pushing the boulder uphill. It really is a big difference. And then there's the culture in the company. Right? We've got lots of people who have a lot of experience, and most of it's due to these double way. And it's often very difficult to get over. All right. So why don't we talk a little bit about GPON? So GPON is Gigabit Passive Optical Network. It's a way to light up a fiber one time in expensive laser upstream, and then have multiple customers attached on the other side. And so, you know, in the extreme cases, there's 4, or 2, and sometimes there's fewer customers than that. But essentially, there is a here, current generation, sort of 2.5 gigabits going down for the customers, and 1.25 coming back up. And this is a very popular. It's built, it's standardized and built almost all over the world. There's also an Ethernet-centric called EPON that's from for some cases. So, residential and some degree business locations get connected to this passive optical network, and then there's an optical line termination device called Telco. And it's basically a box that has lots and lots of line parts to terminate this over and over and over. But also, just like I showed you before, it has other functions as well. And usually these things advocate those customers up into, let's say, 10 gig or some group of 10 gig interfaces, and then they go up to what we call the broadband network gateway. That's usually where the IP address is assigned for subscriber to get. So this is not unlike what you find in the broadband forum specifications right now.
Where would a pawn splitter this?
That's a good question. So these splitters are really small. I've got one right here. They're about that large, and they can be buried underground. They can be put in the air. They can be put in a giant molded enclosure, and they're just gone. They become part of the cable after a while. And so they're passive. There's no active electronics in it at all. So unless they got run over by a truck, they tend not to break, which is good because they're typically outside the campus, not in the central office, but out. Usually, these things are in a central office, right? There's about 20 clicks of range between OLC and customers, and that usually gets back to the central office. But flip. So obviously, you know the coupons on the menu today, right? So why don't we have a little bit more look at what happens inside OLC. So I look at one of those boxes, and I start pulling the blades out and looking at what they come up. This is what I come up with. So I've got here fabric for switching and routing, right? I've got probably some software and management cards that provides you know, the SMMP or the management interfaces. They have some simple control planes. One of the reasons to pick this as a sort of first example is that we don't appear with other carriers using BGP on an OLC. Okay? You might have some IGMP snooping, that might be like your hard control plane built from the cloud. And then we've got lots of line cards, and the line cards have the following characteristics. They got a lot of these spots that light up GPON. They have some manager to it that then manages those spots, and then they link back to the, I'm sorry, I couldn't this one. They link back to the fabric that's in that box. Well, the interesting thing here is that for these functions, basic aggregation, basic management, a lot of those functions I can map into standard high volume devices. Aggregation into a high volume switch, a rack switch. The server into VMs in compute and standard high volume. There's another server there that's actually going to do the management part of the OLT. And then what it leaves, sort of what the remainder is, at 5% from earlier, are these files, the standard sort of OLT 5 chip. And that's exactly what we're going to do in the next picture. We're going to take those files and attach them to the two structure. And we're basically going to say, okay, I don't have to have it all in one box. I can distribute this around. So obviously I need to have a Mac. I need to have the file for that GPON. It doesn't need to do much more than that. But just leave it there. You're going to attach it to standard key switches. Because guess what? That's a really inexpensive way to aggregate in the data center. And then using SDN and NFV managers, what I can do, I can direct the behavior of the fabric and that on that, so that it makes the behavior of, let's say, an Ethernet switch, or the fairly nearly Ethernet switch that I told. And then if I wanted to, I could even have per subscriber behaviors that get encompassed in compute. Okay? So I know this is virtual image. Since Orange, you're here, I know 3 years ago I spent time talking to David Minogue, and there is a virtual residential gateway concept that Telco Orange pioneered at the time. And it was very much like for residential gateways running virtual machines. I would argue that we have that running virtual. It's not that different from the first subscriber that PNG had at the time. So this is obviously where we're going. How I would expect to distribute the functions in an OLT. Yeah. Well, I'm sorry. The question was about the VRAS software. So VNG and VRAS are very similar. This broadband network gateway usually means it's not doing ATM, it's doing Ethernet instead, where VRAS does ATM. Created long ago, VNG does Ethernet. And in that previous chart, it was a standalone box. In this chart, I'm proposing that it will become a virtual network function. But I'm not going to demonstrate that part today. Okay, did that answer your question? So in the standalone box, here, in the standalone box, it's a vertically integrated device. It usually has, well, it has the same components we just talked about. It's got fabric, it's got line parts, and then there are multiple different sort of topologies or architectures that body use. Many of them have lots and lots of processor blades that go inside, and so they'll turn lots of usually terminate a lot of VLANs. And so each VLAN for a customer winds up being a sort of an IP interface. You got to scale those out a lot to sort of a box like that. Real world might have, let's say, 64,000 IP interfaces in it. That's about it. Okay. So
I think the important thing is that that's a function, because those server blades are standard x86 chassis that's called a BSG, and those can be virtualized and then run together or chained together, if you will, between the needs of the customer. Because business customer might get a different service than the residential customer, and so you can construct those as DNS and reuse over and over again that same pattern. Just
right.
Deploy as many times as you need. But you may need all the functions. Each BNG may have a lot of functions that aren't actually turned on for an application. And here you right size it, but just those functions that you need to provide for that customer.
That was a good, thank you. Couldn't have said it better. So on this chart, I'm going to show that I could actually listen to folks from IT. So my colleague here, Munir, actually has the issue of implementing new equipment when it comes into HTTP. And one of the things that's irksome is every time you either want to upgrade or change a model, even sometimes if it's from the same vendor, the next model of the same thing winds up being done all over from scratch, right? You have to do management interface, you have to have new ways to inventory and deal with it. And so how could you simplify that part of the problem? And so one of the things that we do here is I want to show that so we have this hardware we talked about in the last chart that GPON Mac applied, and everything about it is modularized in a way so that you get the maximum amount of reuse functionality. And if you have to change out something, let's say I'm done with GPON and I want to go to XGPON or NGPON. They have other things. There's always another flavor, a little bit faster. I don't want to have to rewrite everything that I've done in order to make that work. I want sort of minimal kind of thing. And so what happens is if I have firmware and hardware drivers that are not sort of intrinsically part of the box, I actually think about driving those chips from an external server. What I get is this ability to go from sort of a proprietary realm into a common set of abstractions. And so through OpenFlow agents and NetConf and Yang, I intend to make this thing extremely generic systems applications upstream. So what we did is we took sort of the OOC guide and the OOC stack, one stack proprietary language, well, standard language that's kind of that's spoken over GPON configured. And we created a set of agents that would then allow you to and create configuration, make the GPON work as if it were just an Ethernet switch from layer. So the same kinds of, let's say, the game theory would be bring up OpenStack and to configure through Neutron some kind of topology, and it would work on GPON, not just on a data center, right? That's a win, right? That's not writing a lot of IT code over and over. And that's exactly what we have, right? And this is what they also kind of see in the But any questions so far? Or comments? Is it fun? Is it interesting? Oh yeah? Okay, so here. So here we go. Why don't we take it? That was a little more specific than the high level hand waving that came before it. Why don't we go one layer more? And this is now where I think OCP really matters. Because here we have a community. We have people that are interested in this area, right? Although otherwise you would be in the room. And one of the things we think makes sense, AT&T makes sense, is that GPON is not a commercial technology. Almost every wireline carrier on the planet uses it. Why wouldn't we collaborate on solutions? And why wouldn't we go right toward solutions instead of going to, I don't know, SC, right? Reasons for these. So here we go again, another variation of the theme on a slide that we saw earlier. For the traditional OLT line part, we're going to mix a lot of the things that are on there, just be max, not even all the memory, and then put them on a platform all by itself. So we partnered and found on OLT map. They just happen to have a 10 gig uplink. Guess what? That's a good sweet spot for copper racks. And the 10 gig gets filled with 4 PON ports, and if you remember, that's 2.5 gig down and 1 quarter up. 2.5 by 4, it's perfect. No oversubscription. There's no, I got to worry about the QoS and the back, and the uplinks and all that kind of, weird stuff that people don't. Okay. And so we think we can put a lot of those on a card and come up with one rack unit design where on the front you might have, this is an example, you might have 24 ports of PON on the front. And you have your 10 gig and some standby 10 gig couplings on the back. But guess what? You could fit just as easily 48 ports of PON, not 16, 30, 48 ports of PON in a one rack unit device, and then wire that all into your top of box. That's 180 gig, well, that's the math. So it's 2/3 down and 1/3 up, but on the GPON side, that's how much bandwidth you can deliver or up that you could deliver. That's pretty cool. And so we think on this particular, you would start oversubscribing in your top rack switch. So if you look at this is sort of an exemplar layout, right? And so I've got a whole bunch of PHY chips, but you notice what I don't have on the layout. I don't have a processor doing management here. I'm going to do that in a standard server. I don't have the ASIC doing aggregation here because we did that in the top of rack switch. And guess what? I won't always have the same oversubscription level. Right today, a lot of people don't really use all the capacity to get out of PON. But as they move along, what we find is customers make more and more use of their broadband. And what I can do is use more of my links from top of rack switch to spine to increase east-west bandwidth, which is what that whole architecture is about. And I don't have to redesign the card. I don't have to throw this one away because it didn't have enough fabric inside.
Also different application, also different with different over subscription. For example, mobile web workers. So different platforms, different applications.
Maybe these things are being used for the business customer. They're what used to be a lease line. Maybe they use internet, through Metro Forum to their building over GPON. Then you also have the residential. They may have less connection, but they're going to get a much larger circuit over that, bigger than you can make that fit, right size it with using the same component. You can then slice that however, whatever makes sense for you. and re-provision as needed, rather than having to uplift or buy something new for that.
Okay, so that was the that was the example. People, are there any other questions or comments? We talk about the demo we've got and what's going on there.
I want to know. Why?
Okay, yeah, the question was, this example, a lot of what I talked about today was really about wired networks, and does it apply to mobility, right? And specifically mobile edge. So, my argument would be yes, that mobile edge has more control plane activity than GPON might, right? There's a lot more super and a lot tighter super over a mobile network. But in the same way that what I showed here, where you took the sort of bi-level fallacy, put it left it in the soft, called that a new sort of edge for your infrastructure, I believe you could play that same game with mobility, right? I don't think that the XH process people coding for over the air. I don't know, need that in some kind of specialized edge plate. But I think that things like setting up there over right post control, that could be done. This software doesn't somehow. That's all. Okay.
How much of the traffic?
That's a good. Thank you for that question, by the way. So, we've all seen it, and it's true that depending on who and where and when, it's less than half, but not by much. So there's a lot of talk. And remember, I mentioned earlier on that one of the things about SDN is that it could be smarter about forwarding. I could come up with forwarding things other than IP or Ethernet, and there's no standard for this. But I think a lot about forwarding content, not as a bunch of packets, but the time of content. I know it's got to be forwarded in kind of special way or special thing. In the past, there would have been signal sessions, or that kind of thing. But why couldn't the network, its job, almost half the time is moving around content assets? Why shouldn't it have the recognition that content asset it needs to be, played out at a certain way? Right? Those are things that I think SDN can deliver. That it isn't just copying what we already do, but finding the real value out of why you would do it. That's a great question.
The GPON is always compressed data.
Wow, almost all video, right? So there's MPEG-2 is compressed, and MPEG-4, the follow-on H.265, whatever it is, more and more. So there's a compression curve over time. The same content gets smaller and smaller, but of course the screens get larger. We go into the next ultra high def and the super high def in the video involved. So,
but GPON, it's a fiber optic method of connecting a subscriber to your server. It's agnostic to is it video or is it IP? I mean, it's packet. It's going to turn into packets 160 OLT. It's going to decode. That's what that MAC layer does. But the interesting thing with PON is that because those splitters are passive, you don't truck rolls, have to upgrade networks, those kinds of things. But it's once you start talking about can you support HD and Ultra HD, and those are just a matter of endpoints having enough bandwidth to support however it can be compressed, or is it uncompressed. If you're doing a studio to studio link, if that's independent of the GPON itself, or, I mean, you can think of it as, it could be, straight fiber, Ethernet over fiber, direct to every house, because at some point you could argue, you run out of the splitters because, you then split among people as the rate goes higher, you may end up just with a straight fiber network. But I mean, it's not any, it in and of itself, GPON doesn't do anything other than allow the provider to not have to direct run cable from central office to subscriber, but they can run, 500 pair count to some splitters, split that out, another 500 or 500 fiber count, right? Then to the neighborhood, 500 from there, and fan it out without having to run so many cables. Right?
Now, the reason I was asking is that if, when you put the Mac there, and it also optionally put a decoder there as well. And hands-on, had uncoded, uncompressed video either going out or coming in, could elect to do decompression there at that point, Mac, or sending it back into your switch, your spine board.
Well, so I tell you, so think about this as well, right? So you've got you have a lot of customers
Let me finish.
that have a box, right? And so when you need to upgrade your set-top box, whatever,
Yeah.
there's a lot of truck rolls.
Yeah.
Right? The thing would be, you could get to the point to say, maybe mail it out, they plug it, you upgrade as much as you can in your facility, data. So there, I think that's kind of what you're driving at, though, right? Where you really want to, have a best buy box as stupid as possible that the customer can have, and then you do as much as you can, like the virtual CP, right? So today you got a CP at your house, and it's got some intelligence, and perhaps like you may have a VLAN for your VoIP service, you have a VLAN for your your video, and a VLAN for your data, right? And it has then all this QoS mechanism built into that box. If you can put that back to the CO, you can then upgrade that, and it's a virtual function, right? Now, and then you can update that as a service as well. And then over that same thing, you might have to upgrade the customer as well.
So I think one of your earlier questions was, could you connect GPON or encoders and whatnot? Definitely. It's quite often, quite common on termination, and the rest of the home router find those. Usually, or kind of right next to the set-top box. Now that might not always be the case. Internet connectivity have and then might have used back the nut to create some type of virtual set-top box. I don't know where, and you might be able to get away from that model, but that's
What's that important? Views different.
yes. Not so much. So the question was, do you think that you need special chipsets in hosts to run VMS? And there are exceptions, like to every rule, right? But generally speaking, most control planes don't. Most quality things like this are so, they're easily segmentable, they're easily scaled out. So if I want to have a virtual machine, and I'm scaling it out with capacity for essentially this box here, right? That I can have a scale out design where I don't need to have especially kind of special hardware. And I might not quite as efficient kind of boxes. But guess what? Licenses are very expensive and very there's some specialized hardware on them. So
You also need to kind of to report that you had an outage because you won't have so many subscribers on each function. You have a bunch of functions where you lose one box. And you lose that OC3, go into a bunch of into broadband gateways, and then it gets restored, and your BNG can't set up but so many sessions a minute, and you calculate how long it's going to take before everybody gets their address again, right? Where here you got smaller, I'm only handling 10. Okay, I'm back now.
Just if I never had memorized.
Right. Right.
but there are some interesting things. So, Josh, one of these pictures here, where actually they were talking a lot about geoconstraint. This idea, I view these as I/O and sort of abstracted because I don't use geoconstraint, right? And what I found is that these solutions and storage are high capacity, low cost, shallow life, by and large. And if I want to create an architecture like this, either non-blocking or very lightly oversubscribed, so I don't want to have a bunch of heavy traffic in here, right? Then I might still use something different here. Service, right? In the network internet, I have all this many networks, right? I've got the OEM, these kinds of lock, I've got very tiny signal beyond what has been in order to provide a quote metro Ethernet service. And where when you have a WAN, it's first. You want to something that's not part of that, that's actually sort of on architecture, right? It might be another thing that provides some rack, provides Ethernet interface that now have Ethernet OEM that have tiny on it, right? That have like network paths like yes, exactly. And so from an SD controller and SD manager perspective, always those large scalable network elements with various kinds of technologies. And so I can slice it and dice it, create many of them for myself and many competitors. Yeah, I don't think of it that way. I often think about the IO box, not speak, well, that BGP is still an appropriate protocol to go between offices and carriers, no problem. But often I think about the SDN controller being the BGP speaker. It hides the complexity of all of the components that make up my office, and it offers up you one virtual route function. And so the SDN controller then populates forwarding rules. So it's as if the SDN controller is the BGP controller from the router, in the same way that a typical router populates on the line cards. Overflow or some other kind of div construct in okay, so how about that demo? Okay. Here we go. So what we have is, I've drawn a picture here to help you see what's on the table. What we have at the left side here, on top, is a Cisco access router. It's one of their 800 series routers. And what it's doing is creating a VPN tunnel back to our lab so we get a live stream of UVerse right here. Right? So all it's doing is bringing in the unicast and the multicast. There's DHCP servers back there and all that kind of good stuff. And then Right underneath it, I've got a plain Ethernet switch, and that's what I've called there my fabric top of rack switch. And in this case, it's actually doing something for me. It's taking the gigi that came out of the 800, and it's giving me a 10 gig interface to go into the GPON OLT-IO. This big white box in the front is this OLT-IO. It's a development unit that comes from PMC. It has just one of those chips that we talked about earlier. And so it has 10 gig in and 4 GPONs coming out. And so on one of those, I've actually got a GPON with a splitter. You can come and see that. And it goes to the other side, which is the ONT that sits in the customer's household. The laptop back here is my STM controller that's telling the GPON system what it should do. And then finally, I have, once again, we called it a home router, but they gave me another one of those Cisco 800 boxes. And behind it, I've got a set-top box. This is our reverse set-top box. It's got our IPTV is live. It's multicast right here. And then also I've got, I've got a screensaver with Rudyard's Family on it. But the upshot is the laptop is doing internet access. So he could do a speed test here. We could figure out how much bandwidth they gave me for this, right? There's, earlier we discovered it was just under 20 meg. And, you know, given the equipment on the table, we know that 20 meg limit didn't come from here. All right. And so you guys are welcome to come up here. What we really intend to do is working here. We're looking for collaborators. This is still just a development kit, right? It's something that we could cobble together some software and get going. But the game is really about what I showed you before. Something that would be in one rack unit that might 24 or 48, or maybe we want the sleds, like our common in OCP. We've got 12 ports per sled, and you populate different densities. So we'd like to actually do that. So I think we get the fact that you don't do standards. But we want to do this. We actually think it's cool, and it'll get done.
Well, but I don't think you have, you know, the standards. I mean, while we don't do standards, we talked about a whole bunch, a raft of standards, both on, you know, the telco side, starting with GPON, right? But at the same time, while Open Compute doesn't do standards, it has a lot of embedded standards in it. Let's say TCI.
Yep.
Okay.
Yes.
So it's not that there is no standards, but for this application, because you put it together, you've actually shown disaggregation in software and hardware that exists. Those standards can evolve on the telco side that needs standardization, because you're going to want to have economies of scale at that line card, right? That's a specialized piece. That's that small piece special, but we still want economies of scale out of that. Everybody using a common design needs to be standardized so multiple people. The same way PCI continues to increase. There's new standards coming up for ways chips connect into memory. All that stuff will evolve. We'll consume, but you know, we're not going to waste the time here debating, you know, how should it evolve, right?
Yeah,
I think so.
I mean, you know, the disaggregated, you know, to take an example, by the way, so that we didn't talk about from an AT&T standpoint that I know is actually quite interesting, is the disaggregation in compute, where you have compute blades, network blades, storage, and then in software you compose the server feed. Because today in NFV, for instance, you go, oh, well, I need like 4 CPUs and so you go, oh, that just becomes something I define in software. Give me 4 CPUs, give me this much memory, give me this much storage, and then that gets reused into the VNF. But then when that's no longer needed, maybe even, you know, we want to do it quick, right? It may be torn back apart and that hardware repurposed for a different. So think about business in the daytime, consumers at night. You may reprovision that hardware, and instead of having server blades for that, you may software configure the hardware to meet that need. And in the real case, you talk about things like Manhattan for cell phone versus Long Island and all the suburbs. So in the morning, you have this big influx, and then it goes back. And so you then want to, those where you get your cloud, maybe your IT functions migrate out to the suburbs during the day, you move them back in, along with like a software-defined radio or something, right? So you can even reuse that spectral bandwidth for other purposes as well. So that entire, we're kind of looking at a really small thing, but it's really a big area that has a lot in common, and especially the principle, right? This reuse, this aggregation, software-defined, it's all permeates this entire.
Yeah. So let me.
Our thinking right now, right?
Yeah, but you're
Let me
thinking
talk
right.
about a couple of things. One was my comment earlier about, I'll turn around so you don't talk to my back. So the notion of, we aren't a standards body, right? That's kind of my opinion that OCP isn't a standards body. In the traditional sense where you get together and you author a standard, and then once it gets to 1.0, then you go ahead and start, developing a product to write code to. It is a standards body in that you have mutual interests and you align to a good idea. And by default, that good idea becomes a standard because you have a bunch of people that adopt it. And so in this case, you have an idea of a GPON line card or interface box, and you have a couple of people that together have developed this. You think it's a good idea. It gets shared back to the community, and if it's a good idea, people will pick up on it and say, hey, I like that idea. And actually, you hope that they like it because ultimately, the more people that onboard, the more it drives volume, the more it drives the commodity pricing, right? And a supply chain, so it's not a custom that it takes 6 months to put it online. But also, in the long run, the more people that have adopted it, the more opportunity that they have to innovate onto it, and that innovation then kind of shares the burden of refreshing the technology, of refreshing the hardware platform.
Yeah.
And so, we are kind of a specifications become de facto standards.
Yeah.
And I think of the MES card as an example. When I say MES card, it's a little mezzanine card. It's we'll see it on the show, but it's roughly 2 inches by 4 inches. It's has there's usually some network silicon and a couple of QFP plus ports on it.
What I'm saying is those are more mechanical specifications.
Yes.
And, we want it packaged in a certain way. We don't want anything special necessarily from the interfaces. If it were packaged this way, it would fit better. It would get, it would fit into the modular, part, which, will evolve over time as well.
So there's a couple of software.
Standard much, BGP, OSPF, PCI, even to some extent like IPMI, like Redfish gives us some capabilities on top of that, I2C. I mean, these things are not changing.
Right.
I mean, they could, right? I mean, we'll come up with, we don't need all the features of that, but that really becomes kind of like a Metro Ethernet forum or ATM forum kind of thing from Telco where, there's a whole bunch of standards, but we have a profile. We want this and this and this and this and this and this, right? And the question becomes, you know, you've got merchant silicon. So for instance, your voice over IP ATA, right? Pick it up, it converted, you know, your PSTN to voice over IP. So that chip was produced in volume, and it does things like pulse dial for you. So pulse dialing still works. It's a legacy. Maybe somebody's new silicon won't have that in it, but you just kind of get it whether you use it or not.
Right.
Right? And so I see a lot of what we need to do here as well is to then kind of specify this is the path we want to take through these standards. And if you're spinning a new one, guess what? We don't need all of that. If that cuts out, gives you extra gates, gives you more capability, less cost,
Right.
simpler, there's less things to debug that go wrong, or that interfere with this, maybe.
So
So
let
for
me.
me, I think there's, you know, the upshot is that you can come to consensus as a community on ways to do things.
Mhm.
One of them, and it might be our trouble with standards, one of them is you would go to Pedro, right?
Yeah. Yeah.
Right? And you would go there, you would send guys with
Right.
ties, you know, instead of hot
Yeah.
chocolate and Geneva,
Yep.
and they would generate standards. And then there's sort of like the open source thing, right? People would get together toward a common goal. They put something together, and if there's value in that, more people jump on, right? And that's also, it's a de facto standard at the end.
Well, that's right.
But in many ways, I would argue, you get to where you want to go quicker.
So
You have
we did,
more help getting there, and you have help keeping it.
so we did that with the switch abstraction interface.
Yeah.
And I think that's an example where we got together, we quickly wrote that API interface for the switch. We got the community involved in piecing of everything together. At that point, there was kind of choice. You either go to a standards body like DTMF, as an example, or ETSI, and that may take a year to get it adopted. And of course, once you go to the standards body, then you got to go through the whole voting process. Instead, that just simply went to the network community. The work group said, "Yeah, I reviewed the spec. Good." How many people say, "Yeah"? No.
Yeah, but you weren't changing
And
IEEE
No.
802.3
right.
or adding, that's going to go through and it's going to take its time. But you could innovate and you can actually, have that innovation baked into product that you can buy and deploy, and it may be 5 years before the standard comes out. I mean, we've had many examples of that.
And the standard could actually,
It
standard could
follows
fall out of
later.
that.
Yeah,
That's
yeah.
right.
And it may
Yeah.
not even be what's deployed, like
Right.
the case of pseudo-wire, for instance. I was involved in that, right? So I had a draft from a buddy of mine, Luca Martini, that everybody uses, and the RFC version of that is totally different than that. But yet, that's what's actually implemented.
And I think that another example is, Redfish is going through a standards body, right?
Right.
Intel is actually looking at using Redfish and building on top of that.
Yeah.
That probably won't go to a standards body
Yeah, yeah.
necessarily, because
Well, that's it. Because
and that's where you're kind
the
of building on
interface-
top to go
Yeah,
fast.
the interfaces are going to be defined, well defined, so that not only can Intel add value, other people can add value to that interface.
Yeah.
Right? That's all we need. The standard is this place where they meet.
Yeah.
But what we don't, I think the agreement is that the traditional, when I think of standards, because I'm Telco, I think of like the CCITT or the ITU now, and basically everyone got together all around the world and agreed this is how we're going to pass telephone traffic between everyone, and we're going to have this, and now the vendors can now do this, we're all going to buy it, and for the next 10 years we'll
Mm-hmm.
all consume it, and these are the services we're going to sell. But we're in that, the services have accelerated, and the standards have accelerated. That model doesn't work. We have to have some agreement on standards, otherwise you get a plethora of one-offs.
Right. Right. The beauty that I like about this concept is that it builds off of, it leverages, the hyperscale compute hardware. It actually leverages everything that the network group is doing, and the relief and spine concepts and the data plane. It doesn't. I mean, I don't think there's. Seems to me like it's completely consistent with that. Yeah.
We were trying to.
It really is. There's not a storage component in it, but certainly, storage is part of that as well.
I think it has similarities. Sort of a.
Yeah, having said,
Yes, absolutely. So when I think about, picture before, when I think about the entire infrastructure, given location, I can see a bigger switch logically over this infrastructure. Line cards are played that come from GPON, Metro Ethernet, and other things, right? These
But we kind of have that somewhat today, right?
You do?
I was at level
Yeah.
3, and we, our gateway design basically was built around, 2 switches, and then your, edge equipment, uplink Ethernet, the core routers, took the Ethernet, your access routers, took it, your voice over IP equipment, spoke Ethernet, and that's kind of the exact same thing. Now we're just wanting to take it and pull out that control part. And for me, I really want to take out as much of that network as well, instead of having these large pipes, which end up with a large failure domain. We can fan it out to any smaller ones because of flow. If you're talking 10 gig switching, you got a flow that's you're not even gonna get a flow of 1 gig to a home, right? I mean, it's kind of like
during the speed test.
yeah, but these are, except for speed tests. Even then, you're a 1 gig. You don't have a 1 gig connection to a home. There's not even a single flow that large, and so you can always fan out those flows. We've always had clause matrix. And, now
Right.
you've got a non-deterministic matrix with Ethernet switch. It's a little interesting, but with a little oversubscription, you don't really care. But anyway, sorry.
Yes.
And what's the real mistake for us being
Oh, wow. That's just get a sense.
Yeah.
It's still small. It's still small. Like oh gosh. I would let maybe Yana speak to that, but I believe you could get this into sort of an arm report. Doesn't need to be okay. And depends how much you want to be done. Okay. What we're doing in this demo is sort of a fairly static demonstration, right? We set up the connectivity and we the multicast. So there's not a lot of dynamic going on in both things. If you scale this, I would expect that more color. And it's one of the things that I like about this. While it's drawn to the side here because that's how we're demoing it. That's how the development kit works. In our plan, we keep top of practice. And controllable by any so it's still independent. If you don't pass it, you know, very modest. So, right? You a lot of passes that $600. No, some number of controllers. In general, my philosophy about controllers are they're hierarchical and have small domains that they mess with, right? So, Yes, that kind of model, or in that model, we may actually you may actually sort of hand out part of the control to the container, right? So some policies might be appropriate for the container to manage, and the decentralized sort of common control looks more like I don't know, like more like an arbitrary or multi-function. Now, there's a lot of fun things. There hasn't been enough time to explore all those really interesting ways to architect make it work.
How do people on that?
Yes, just the diagram. So we're interested in making, right? And but we don't think that AT&T should pay for themselves, right? I'd like to get other people sense for if this is something they'd like to do, share in sort of what makes sense in one of these one rack unit things. You know, do you want to have pluggable optics, or should all come in with? I don't know. It's the obvious choice, right? And there are other, we could get into it, there's a bunch of little choices to make along the path. And the idea, I think, part of the community is making sure everyone is served, right? And that therefore you get the inputs and sort of the pushing on the wheel from all the
For example, base but four. In mind, the weekend and four. Use 10 times less fast. There are several resources that we know that when we cannot aggregate in the line, but it's web. Okay, so several things together. We know that even the compound, right? One makes the execution power.
One of the things to sort of put that on here, that if you were to do aggregation in the box, you can think about putting sort of Broadcom ASIC here that have many fewer uplink ports, right? But then you'd be making choices about you duplicate, and we have two of them for redundancy, and how much to oversubscribe the bandwidth now. This model, it looks, you know, standard telco mentality, the way I would have thought 5 years ago, is there's a lot of people, 10 gig ports on the back of that. It seems wasteful, proper large switching ports. But I can use the simplex model with no redundancy. I can use it with redundant ports to one or two top of rack switches. And the same layout, the same SKU winds up serving multiple different kinds of deployment models. Do I do want the fault tolerance, or don't want the fault tolerance? Do I want lots of bandwidth enabled to aggregate, or I want to overstrike it out the wazoo? I can make that choice option, like, which I think that has value. But that's my thing. That's another question. There's some overlap with the NOR. That was it. I think that was the point. Maybe so your question is, could you eliminate the taco rack switch if you were to put the aggregation piece on the board? Yes. But in that model, I would say you would have to make some choices. have to pin something down, you put both TOR, which is inside this box, or do you do something else, right? It's a good question, and it's worth discussion, I'm sure.
Well, what's happening?
Uh-huh.
Right, no, that's why you would be done. Diagram we showed at the beginning, okay? If you look at the GPON NFV card, so it's 10 gig. It's 4 phones with 10 gig. We have actually two 10 gig. One goes to one top of flex switch, the other goes to another, and you manage redundancy as in other application server.
Yeah.
Yeah. My question would be more around, would you want to make a GPON mezzanine?
Yeah,
Or,
we talked about that too.
Because in the current design, there's just one.
Yeah.
Maybe it could be a PCI attached thing.
So-
You could add to some.
Yeah, no, this is actually where we
It's,
started
interesting. Because
when
then you're not having to run, how many Ethernets you put, all you're worrying about the thing you're trying to adapt. You're not putting
Right.
a double adaption.
So that's a good question, and that's actually where we started. When we first had discussions about this, we thought about a GPON NIC for a server.
Yep.
And guess what? The GPON and the server share a fate domain, right?
Yes, they do.
GPON works, server works. GPON's dead, I use that server, right? I mean, right? So one of the first things that we said was, well, gosh, maybe we should decouple that, right? So if I have the wiring out to the customer is hard to change. If you have fabric into a server goes bad, Neutron will rewire it in a hurry, right? But if I put a GPON NIC right into a server, that server is pinned down to those customers. There's not some easy way to go through the fabric to rewire the GPON file. So that's why we decided, no, we didn't want to share fate with the server. Yeah.
Yeah, so I'll tell you, I've been doing cloud and telcos for a long time. There was like the question came up about where you split out. Here's the piece that's special. And so I always use the analogy of a printer. Because people are like, well, what can you not do in the cloud? Because you're thinking, oh, you can do anything with the cloud. You're like, well, take a laser printer, right?
Yep.
I can do everything that a laser printer can do, with one exception, and that's put ink on the paper.
Right.
Right? Where the ink goes on the paper. So there's a physical boundary. So in this case, you're going photons to a wire.
Right.
Or to a fiber. Right? Or in radio case, you can do everything software-defined radio except for that air boundary. Right? And so, to me, that's the only part that needs to be special. The rest of it, your fake sharing, we need to come up with a way to switch the connections, which probably could be done through Ethernet or something as well. So if that server dies, you don't worry that you had only one small set of subscribers that were affected. They quickly healed. Maybe
right.
Right.
In this architecture, I believe that will be the case.
Being shared, that the more faith you put into this one, you then have to continue then to not over-engineer, but engineer two power supplies, two, and so all this redundancy. Now you got two of them.
Right.
Well, if I just had two of them in that.
Right.
So it's like, I always try to get down, that smallest thing. What is the difference that I can't do any other way?
Right.
And then the problem is still that capacity planning thing that runs around in the head, right? It's like, because now you got these special servers with that special card where if you have, the line card or that skid, you then have, how many of those do I have? How many customers?
Well, they're less like cattle and more like pets if you start specializing in serving, right? So, yeah.
So,
I think we're on the same
we'll
wavelength,
stop
right?
there. Yeah, I think there's some ways around it.
Tom, do you have you have a call to action or next steps you'd like to take with this?
Well, thank you.
Okay.
What a great segue. Yeah, so obviously we have some concepts. We're looking for folks who are interested. I think that if this is a telco working group at OCP, I would be very hopeful that this would be the kind of thing that folks would be interested in. And AT&T is definitely interested in collaborating on exactly this. So that call to action would be, here's a work group. Here's a work group. I understand it's getting started.
Yeah.
We got a problem. Actually, this is okay. I'm going to make one other economic sort of spin on the ball. Okay. If you look at all the places that we could direct the new technology, we could be looking at core routers, right? But they're big and they're honking, and everybody loves to talk about how many massive amounts of bandwidth they do. But if you look at the books, if you look at the finance office, where did they actually spend all the money? The core routers are nothing. I mean, they get all of the highlights and all the glam shots, right? But all the money they spend on cell towers and on GPON and on G.fast and things at the edge of the network. For guess what? It's simple, has a small crater size if it doesn't work perfect the first time, and if you apply this technology and it makes a big economic lever shift, it really makes the bottom line in the company shift. And that's what I really want to do, right? So,
okay, I think that's
so there was my,
I think that's very reasonable. I think that this is a perfect forum to do that. And actually, this is a perfect product. It's technically, it's not, it's something that we can handle and be successful in a relatively short period of time. And come back a year from now and demonstrate this.
Absolutely.
So, so in terms of the work group, where do we go from here? The other work groups meet on a regular basis. Usually, once a month we have a call, maybe every 2 weeks in some of the more active work groups like the server work group. What we need to do is to set up make sure that everybody is subscribed to the telco work group reflector. And then in the coming weeks after this meeting, I will work with Amber to schedule a call, and I think what I'll do is work with Tom and see when you're ready to present again in the work group.
Okay.
And I'm thinking that what we want to do is maybe put this down into get kind of following some of the other models that have worked, kind of an initial document or I hate to say it, spec, but kind of product description on what we think it should be. Once we get it down on paper where we can share it with the community, everybody then can make comments on that. And then we get back together at meetings, and then we capture all these comments, and Tom can then take that and scribe that back into a proposed spec, and then we also have an opportunity to, work with the supplier base to do something. So,
great.
So the next step is, in the next month we'll put together our first, working work group meeting.
Okay.
You guys will have to make sure you subscribe through Open Compute to that work group and to get connected. And if for some reason you have any questions, always contact Amber for everything. Okay? But she's very good at it, and she'll make sure it gets. First off, she controls the mailing list, so she'll make sure you're on that. And then when we get a meeting, she'll also make sure that if you've said, "Hey, I want to be part of this," that she'll send it out and make sure you're part of it. Yeah, so the work group the mailing list was set up right before the Paris event. I think they announced that they were going to do it. The thing is, it's a reflector. If no one writes to that work group, nobody sends out a message, nobody gets a message. Oh, is that right? Okay, I'll take that action and work with Amber and make sure that on the OCP portal that there's a place to find it and to get signed up.
as
We need to create a wiki
or
for that, yes.
incubation work
Yeah.
groups or
Yeah.
something, because it's not a real work group, so they can listen.
So
So you really can't find
that's right. So
anything.
by the way, there is a
Yeah.
wiki, there's a wiki page for the Telco work group. They're redoing it. She didn't want to turn it on until she turns on the kind of the new portal, and then it'll be included. There's a proposed charter that I had put together, gosh, almost a year ago. That'll be kind of the initial, charter for that. It'll serve as a place to start posting information and downloading it, things like this that we can share public.
I'll tell you, I think there's one additional place that Telco needs is in the operations group as
Mhm.
well. Because, telcos have a rich history of operations. And it's a very different thing from data center management. Now, it's similar, but a little bit different. And so, from my point of view, after talking to telcos as well, right, that there's a checkbox for devs, which, well, you don't really do devs anyway, but it's a checkbox because that part of the organization hadn't thought of. And then once you've done a proof of concept, you want to move it into a trial, you then go talk to the operations group about actually deploying it, and the language is mismatched, right? And so I think that there needs to be, I don't know if the telco work group should have like a group, but the operators need to have their operational practices mapped more than anything. Right?
Yeah. So did you listen to Jason this morning?
Oh, yeah.
Yeah, talk about that?
Yeah.
So we're right in the midst of changing the charter for that data center group.
Yeah.
And our thought was that group was originally set up to focus on data center design. The problem is that everybody's data center has a unique set of needs, a different locale, different building codes. There was never anything we could do that was common. So we said, let's go refocus that group and look at operations. I think that is exactly what we should do, and that this group would have huge opportunity to contribute into that with practices that you
I
already
think like
have.
the same thing, there's that 5% telco,
Yeah.
and then you'll find that there's actually a 5% IT that really is not part of the core once you kind of start going, everybody's on an equal footing. It's not, everything has data center IT, really cloud operators versus IT, and you say enterprise, that's more of the model that we'll see too. And I think this should probably be, a focus area for that.
Okay. Yeah.
All
Okay.
of those telecom issues.
Well, that
so
and
what's the inhibitor of hyperscale? Right?
Okay.
One of the inhibitors is that the advanced technology groups get it, the executives get it from the bottom line, but then when it gets passed on to the rank and file, the message gets lost. And the only way to address that is to have documentation, specifications for them to read and go, oh yeah, that's the same thing we're talking about. Oh yeah, I see how that maps.
Yeah. So, one of the things I wanted to do is make sure that this community gets connected to work. I said I was going to try to get us done by 3:30 so they go visit another group. We're already over by a few minutes, but just to kind of give you a flavor, so the attendance was capped off at 400 people registered for today, and a lot of people were not able to register because registration closed in a matter of a week or two. I think there's going to be about 3,000 plus people here tomorrow, and quite a few more people. I think there's probably some people that are from the carriers that will be here tomorrow. My plan for, we have breakout sessions tomorrow and Wednesday, my plan for tomorrow for the communications work group, this work group breakout session was to have Kevin do the same presentation, have Tom go through the same thing, and then I've asked Carlos, who is the chair of the networking work group, to come in and spend an hour and go through what all the things that they have, so you kind of get an idea, and have a chance to kind of talk directly on the stuff that they're doing, some of the switch contributions that are going on, the switch abstraction interface that they're working on, ONI, those types of things, and just give you a chance to, talk to that worker. That's tomorrow's agenda. Still gives you some time to connect with some of those other work groups. So if you wanted to skip Kevin's at first hour, that's fine. He'll understand.
I think though
But I think we're going to see a whole new.
I think what you'll find
we're going to see some new faces tomorrow.
So you basically like the NFV, their the infrastructure, right?
Mm-hmm.
That ended up getting a lot of operator input and a supplier input, which said we have ACTA, we've gone to Blades. Blades are very similar to ACTA in that they have some of the same failure domain issues solved, so that my software doesn't have to solve some of these problems.
Right.
What they see is problems. Right. And so I think more than the network switches, right? As in, networking is really about tools right now. That's not as big of an issue for like the NFVI folks, in my opinion, than the servers, right? Because the servers don't have the redundancy of network interface. They want a lot of interface, a lot of I/O, a lot of CPU. So it's like in the end, it would be a sked for telco.
That's where we started, but it's not where we're going. So, if you remember at the beginning of the talk, we see a lot of examples where people take the code that they've developed for a vertically integrated box and port it to one VM.
Sure.
And then all those issues come out.
Sure.
But I really believe that the software needs to do the availability, not the hardware.
Oh, absolutely.
Right? That's what scale-out system is all about,
absolutely.
right?
Absolutely.
Any shard of the software can fail, and it doesn't matter.
Absolutely. I mean, we're on the same page.
Yeah, that's where we want to get.
But it is the failure domain will be different. I think your point is that we have to address that.
There are some perceived and some real differences, though, in web scale and telco applications that may have some bearing on hardware.
I hope so. I have come to expect that my cell phone call will be dropped. I never lose a Twitter feed. I never lose a Facebook feed. I always lose a wireless call.
Here's the fallacy in that argument. Okay? And the fallacy is that the 3GPP folks at Etsy made an infrastructure, and there's an infrastructure built in such a way that your cell phone works. And those people are the ones that are saying, in order to continue providing your cell phone the services it's getting, this is what we need. Right? So from over the top, those applications, without a doubt.
Yeah,
right? And we have a new one, it's like, we had 5 nines, it's like, no, we have now, web is the thing, right? So when you say google.com, if it doesn't come up, you start fiddling around with your connection. You don't call up and say, hey, is Google broke, right? Oh, let me try it on my cell phone. Let me try it on the computer. Yeah. Because you've got multiple connections.
So
there's a little bit of difference. And like I said, I'm the lunatic fringe over on the edge versus, I accept a little bit of okay, you can drag me towards the middle some. But these are real issues, and there's some, you're not going to be able to overcome those. As trying to sell web scale servers to telcos for the past few years.
I would love to have one of the activities in this work group, people that are intimate with the infrastructure and operation side, and challenge a group of people to look at the web scale hardware and say, how can I put this into my infrastructure? You know, what is the failure domain, and how is it different, and how is it going? What are the things going to prevent me from taking
We just
that
talked
open
about it
compute
another
hardware
second ago.
and do that?
So in his talk, he talked about having, you don't have to worry about oversubscription. It's easy. It maps straight through. We don't have to worry about that.
Mhm.
And then we talked about just a second ago about, oh, we've got these two failover and can fail here quickly, right? And this quickly is a lot quicker than web applications typically have to fail, right? And it's it's the same reason you have MPLS that really runs your IP network, because BGP convergence is about 30 seconds and your IGP is about 1 to 2 seconds. And for voice over IP, we needed something that failed much faster. So you have MPLS with 2 routes and you load both of them in the fib, one fails, it immediately takes the backup path.
I wasn't going to argue that. I was going to argue that a lot of the web scale software actually doesn't experience failures. It experiences loss of capacity. Right?
Well,
the
but
transactions are not even lost.
Yeah.
If you're going to use Cassandra or you're going to use some other type of large web scale database, you could lose a server, you could lose several, and it just double happen.
Well,
Right?
so until
One point of administration.
Yep.
Yeah.
So, in absence of anybody volunteering, easy work group would suggest Bill Carter leads it for now. And that's
Is that a way to get back at me for saying it's okay to not show up at
Apparently.
If that's okay, because we need some formality to this. I think later on there has to be a customer leading it.
Yeah.
But when we raise hands, have Bill do it down. You guys have officiality to do this, and next time somebody else can volunteer.
Well, I'll definitely. I'm gonna keep getting it started through. Yep, that's right, through the foundation. I'm gonna keep pinging people to asking if they're willing to, be the co-chair of the work group. By the way, serving on the work group in OCPs it has a sunset clause in 1 year, so you only have to do it for a year, and then it automatically goes through an election process every year. So finally got that taken care of. So you're looking at, and ideally we'd have, Jeremy, like I mentioned, we'd try to get somebody out of Europe to co-chair it as well.
Is everybody okay with Bill? It's arranged for a time.
Thanks, Larry.
Okay, thanks, Bill.
Okay.
Congratulations,
Thanks,
Bill.
Tom.
Your head is red.
Yeah. Okay. Hey, thanks for everybody for showing up today. Go check in at the other groups. You still got a couple hours with the meeting, so I encourage you. And we may see you tomorrow. Bigger audience.
Hello? The pond is hiding under the controller. So this is my key. My splitter, so 1 to 4 splitter, right? And I have one going out to my and another one just in case I don't want to. Yeah. Very good. Thank you. Hi, Eric. Yes. So, what's also feasible? I'm sorry. Yeah, these are SFPs, just like you would find in.
Yeah, but it's also I need a proper
Yes. There could be. That's one of the other options. But in this case, populate the optics as you go, right? So, another one of those choices of the many choices on the list. Right. So obviously, the interface doesn't represent that. So if there are people who want to see, this is a essentially VPN router. So they gave us a link to the internet. It comes in, we built a funnel back to our lab so that we get feed for users, real multi-cast network. We'll much.